Okay, I want to do an introduction video to the next video. It basically goes over the very basics of the periodic table. There's what are called families, which are in columns of each other. So here's like hydrogen, lithium, sodium, potassium. Anytime they're in the column, they're called a family, and it means they react in a similar fashion. So that's family 1A, or you say group 1A, and this is 2A. These all react in a very similar fashion. You know, over here, fluorine, chlorine, bromine, iodine. Some of them have names. Is here group 7A. You see I'm looking at right here, 7A, fluorine, chlorine, bromine, and iodine. These are called your halogens. Okay, you'll need to know these names. So group 7A, right here, called halogens. Group 8A, which would be helium, neon, argon, krypton, xenon, and so forth. These are called your noble gases. Okay, these are all gases. And noble because they have a full octet. Octet meaning 8. Basically, they have, we have our orbitals S, P, D, F, and basically they have 4 orbitals. Or, since we haven't really got into orbitals, we'll just say they have the max amount of electrons that they can hold, okay, which makes them very stable. When something's reactive, it means it doesn't have enough electrons and it wants to stabilize itself. Well, these noble gases are very stable because they have the max amount that they can carry, so they don't really react. These are also called inert. Inert is just it's I-N-E-R-T. That's just a fancy way of saying not reactive. And again, they're not reactive because they have the full amount of electrons. They have all 8 because they're in group 8. That's the other thing. Valence electrons, those are the outer shells. Those are the electrons that are the furthest away from the nucleus, which means furthest away from the protons. So they're easier to bond with. Okay, so think of the nucleus as like a magnet because it has positive protons in it. And the electrons are, your negative a magnet if you want. Now, when you're working with magnets, does it make sense, right? That the further away the magnets are, the less you feel the pull. When you get the magnets really close together, you can feel that magnetic pull. So the same works with electrons. When you have electrons like further and further away, the protons aren't holding them in as strong, so they can bond. So your valence electrons, also called your bonding electrons, those are the furthest away from the protons or the nucleus. So they're easier to bond because they're not held as strong. Okay? And the valence electrons, you can look at what group they're in and it'll tell you. So there's group 1A. All of these have 1 valence electron. And this is why they react in a similar fashion, because they have the same amount of valence electrons. Group 2A, right here, has 2 valence electrons. 3A has 3. 4A has 4. 5A has 5. 6A right here has 6. And 7A has 7. And 8 has 8. I'm just looking at the group number, the numerical number up there. Notice I did not go over these because these sort of vary. They're a little bit strange. These are called your transition metals. That's this whole block basically right here in the middle. These are your transition metals, and these are your traditional metals you think of, like zinc, gold, silver, titanium, iron, cobalt. These are, again, your transition metals, and they sort of react in a similar way. Okay, these are called your alkali metals, group 1A. These are called your alkaline earth metals, group 2A. These are called halogens right here, group 7A. And these are your noble gases. And those are pretty much the ones you need to know. So your metals are anything that are blue. Okay, so all of these are considered metals. All right here are considered metals, and in this kind of stair step here, this is considered metal. All the green are considered non-metal. And this red here are considered semi-metals. And they have a little bit of properties of metals and a little bit of properties of non-metals. But I would say they're more metallic than they are non-metallic. how they react. So you'll need to know this classification, like which ones are metals, which ones are nonmetals, and which ones are semi-metals. Okay, semi-metals are really good at conducting. You'll also need to know just the alkali metals right here, alkali earth. These are all your transition metals in the middle here, and then halogens and noble gases. Okay, the last thing I want to go over really quick is more about the valence electrons and the charges. Okay, and again in the next lecture it goes into it a little bit more, but let's look at this. So noble gases, this has the max amount of electrons. These are the most stable. So all of the elements on the periodic table pretty much want to be like the noble gases. Okay, so let's look at this. Fluorine, so they all want to have 8, okay, because these have 8 valence electrons. The fluorine has 7, so how many more does it need? 1 more, right? So, okay, think about this. Electrons have a negative charge. Okay, so when I add a negative electron to it, it becomes a -1. Okay, now let's look at the next one, which would be like oxygen group here, group 6A. It needs 2 more electrons. So we're going to add 2 negative charges, so that's going to give a 2- charge. So everything in this column tends, if it's reacting, if it's a acting like a noble gas, it'll have a -2 charge. So basically what it means is if it does have a charge, that charge will be -2. If it does not have a charge, then it's neutral and it still has 6 electrons. So don't get confused and think that every time you see oxygen it has a -2 charge. That's not true, because sometimes it's neutral. But if it does have a charge, it will be -2. And these tend to be -1, again, because they just need 1 more electron. These here, nitrogen, phosphorus, this whole column here, it's 3 away, so it just needs 3 more, so it tends to have a -3. So there's a trend here. See, -1, -2, -3. Carbon right here and silicon, all those, these are a little bit unique because it's like 4, so it's kind of in the middle of 8, so it can sometimes have a +4, sometimes -4. So don't worry so much about carbon. But let's go the other way. Now we're at boron. Now this one's unique because how do you do this? Okay, am I going to add 1, 2, 3, 4, 5 electrons to make it a -5? Or what about if it loses electrons? Okay, so right now it has 5. And I can make it kind of like helium, so if it lost, sorry, it has 3 valence electrons. So it can either gain 5 or lose 3. If it lost 3, so 1, 2, 3, helium, so it lost 3, it's going to be like helium, and it's like a noble gas. So basically, it's easier. So it's lazy. It's going to do what's easiest. Is it going to gain 5 electrons, or is it going to lose 3 electrons? And it's easier to lose 3 versus gaining 5, just because the number is smaller. So if I lose electrons, I become more positive, right? Okay, so the charge here tends to be a +3 because it's going to lose electrons. Now right here, this one here has 2 valence electrons, so again, it's easier to lose 2 than to gain 5, okay? Or sorry, to gain 6. So it tends to have a +2 charge. And this one here, 1A, tends to have a +1 charge. So it goes 1, +1, +2, skip the transition metals, we'll go over those on another time, and then +3, because it's easier that way. So if they do have charges, those are the charges that whole column will have. And over here it goes -1, -2, -3, because at this point it's easier to gain electrons than to lose them. So hopefully that helps, and that's going to get you started for the next vodcast.